on this differential equation. This will be our session third. Okay, and in today's class we will be covering this homogeneous differential equation. Someone has joined. 1 second. Yeah. So in today's class we will be discussing the homogeneous differential equation, the brief introduction of this part, and we will be doing some questions as well on this basis. But let's discuss that. What is the what we have discussed till now? So till now we have discussed the types of solutions of differential equations, right? Types of first order and first degree differential equations. Then we have discussed in the first order and first degree, we have discussed the first method, but that was variable separable, and we have also discussed the equation which are reducible to variable separable form, right? And in today's class we will be discussing the polar coordinate transformations. Okay, like how to convert the Cartesian coordinate into polar or polar into Cartesian. However, you might have studied in the complex equation also, if you remember. Otherwise, we will recap this again, and then we will discuss homogeneous differential equation. What does it mean? What is the homogeneous means? We will discuss that, and the last we will discuss the equation which are reducible to homogeneous form. Okay, so let's start with the first topic: polar coordinate transformation. The first one is polar coordinate transformation. Some of you might be aware about this, what it is actually. So if I say that, let's say a point is being joined from the origin by the length, let's say OP, which is given as length R, right? And on the x-axis we are already having this OX, okay, which is along the x-axis. So the angle of inclination of this line, which we are representing, assuming that it in the vectorial format, okay, so the theta is actually measured in the anti-clockwise direction from the positive x-axis. Okay, this is the theta. So how do we represent the points in the polar coordinate? Coordinates in the polar coordinate r comma theta. Remember, in the case of Cartesian coordinate system, we represent them by x comma y, but in this case we represent them by the r comma theta. Okay, we will understand how to convert them. This theta will always be belong to minus pi to pi. That means we are talking about the principal value only. Okay, and polar coordinates are r comma theta. It is already given. Now let's see. Suppose that if I am projecting this point or projecting this line vertical component here. Okay, so if I apply in this right angle triangle, in the right angle triangle, let's say this value is x. Okay, and let's say this value is y. Actually, these are what? These are, I'm saying, these are the distance of this point in the x direction and y direction, or we can say the abscissa and ordinate of this point. If we are assuming this point in the Cartesian coordinate. Okay, so suppose that if it is x and it is y, so if you write the x component of r, that will become what? X component means this value, this one. This will become r cos theta, and this will become r sin theta. Okay, so it means that if I want to represent my polar coordinate into Cartesian coordinate, then we have to think about these points, or we can say we have to replace this variable, like x is equal to r cos theta and y is equal to r sin theta. Is it clear, everyone? Or is there any doubt? And where do we use this? Yeah.
Clear, sir.
Okay. And where do we use this? Actually, this is the radian scale measurement, you can say, and we also use it in the aircrafts. Okay, in the aircrafts, we generally have these coordinates only, that is the distance and the angle, right? So you can see that these are the polar coordinates and these are the Cartesian coordinate. Now, how they have converted? Of course, from these only. So this is r value and this is theta value. Okay, so if I'm writing here, r is equal to 4 is given, theta is equal to 45 degrees given. When you find out the value of x is equal to r cos theta and r sin theta, you will be getting 4 by root 2 comma 4 by root 2. Okay, very simple thing to convert polar coordinate into Cartesian coordinate. But how will it help in the differential equation? Of course, it will help because there are certain equations, there are certain standard expressions which generally we can directly use these polar substitution. Okay, so let's see. The first one is x dx plus y dy is equal to r dr. Okay, just write down right now. I will tell you the proof also. X dx plus y dy is equal to r dr. X dy minus y dx is equal to r square d theta, and dx square plus dy square is equal to dr square. These three results has been extracted from this polar substitution. And how do we prove? Same LHS and RHS rule, right? Like x value already know, r cos theta, put it here. How do you find out the dx? Differentiate this x with respect to differentiate this x basically. So dx will become r cos theta into r sin theta into d theta with negative sign, and then put it here. So it is just simple, right? Let's see the proof of it. So you can see. Let me change the color. You can see the proof of this, that x square plus y square is equal to r square. Suppose that if it is the expression, already it is coming from whatever we have, right? Because you know that x square, one second. You know that x is equal to r cos theta and y is equal to r sin theta. And if I ask you to find out x square plus y square, you will be definitely getting what? R square cos square theta plus r square sin square theta, which is directly nothing but r square only, because cos square theta plus sin square theta will become 1. Okay. Now, if you differentiate this expression with respect to, or simply differentiate, right? Not with respect to x, simply differentiate. So it will become 2x dx, 2y dy is equal to 2r dr. Then further 2 and 2 will be cancelled out from both the sides, and x dx plus y dy will become r dr. Okay. Right. How do we find out this y by x? Because we already know x is equal to r cos theta and y is equal to r sin theta. If we take the ratio of them, then this will become what? Simply tan theta, which is nothing but y by x. It is coming from here. Okay. If you differentiate this, so in this case, y by x is given, so it will be the u by v rule will be applied, right? So it means the derivative of the first, second as it is, means v as it is, u by v rule, right? So when you do this differentiation, you will be getting sec square theta d theta, and further, when you take this x square on the right side, x square into sec square theta d theta. Okay, left side remains same. X square into sec square theta will become what? You can write this as x square by cos square theta d theta, which is nothing but what? R square. Is this clear? So these two proof we have done. Is this clear?
Yes,
So,
sir.
so what is the use actually? We will be using directly whenever in the differential equation this format x dx plus y dy or x dy minus y dx is given. This is 1, this is 2. Whenever these formats are given, directly replace them by the r and theta or r and dr, whatever is given according to the given expression. Similarly, the second expression we are going to, let's say in this case, we are assuming x is equal to r sec theta and y is equal to r tan theta. This time we are solving, or we are proving the expression which is having negative sign between them. Okay, like this. So x dx minus y dy. How we are getting? So suppose that if x is equal to r sec theta, y is equal to r tan theta, same thing you will do. Take the square and subtract. When you take the square and subtract, r square will be taken as common, and you very well know that sec square theta minus tan square theta is 1. This value is 1. So finally you will be getting this expression. Okay, and the same thing will happen if you take the ratio x by y, r and r is gone. Sec theta upon tan theta. Sec theta is 1 by cos theta. Tan theta is sin theta by cos theta. When you cos theta and cos theta is gone, it will become 1 by sin theta, which is coming here. Okay. Now differentiate that. Okay, differentiate this. When you differentiate this, you will be getting 2x dx minus 2y dy is equal to 2r dr. Again, 2 and 2 will be cancelled out, and you will get this expression. I hope that it is very clear, not confusing anywhere. I have written a lot of things here. Okay.
Yes, sir, clear.
Okay. The last one, x dy. So remember, this is x dx. This one is x dx. But this relation is x dy and y dx. X dy minus y dx can be proved in the similar manner, and this will be coming as r square sec theta d theta. Okay. However, the proof is not very much important, but still we have discussed that. Right. So these are the four results. These are the two. Third one is this one, and fourth this one. Okay. So do write down these results directly, and after this we are going to solve a question based on this method. Okay, let's go. See the question. It says that solve the differential equation x dx plus y dy upon x dy minus y dx is equal to under root 1 minus x square minus y square upon x square plus y square. So I am solving this question. Okay, I am helping out in this question. After that, I'll be asking you the some more questions. Okay, so you can see x dx plus y dy upon x dy minus y dx minus y dx is equal to under root of. Achha, I'm writing this as taking negative sign common, x square plus y square, and in the denominator it will become x square plus y square. Okay, any problem up to here? I don't think so. So after this, what we are going to do? Now try to solve this. Replace the values. Replace the values. So we already understood that the x dx plus y dy is equal to r dr. Okay. Who is it? Hmm. Hmm. So we already understood that. I'm writing here the results in this curly braces. X dx plus y dy is equal to r dr. We have already studied that. Okay. And we also understood that x square plus y square can be written as r square. Okay. So here you can write this as a conversion to polar. Conversion to polar. Similarly, y, sorry, this is x dy. This is x dy, right? Similarly, x dy minus y dx. Can anyone tell me how do we write this value? What is the value of this expression? We just studied that. Which value we should take?
R square secant theta d theta.
R square sec square. But why we can't take this directly r square d theta? Why we are using? Because there is a catch here. What is the catch? You can see x square plus y square is being used here. So if this is the expression is involved, it means that the two results which you are discussing x dx plus y dy, both the results will be taken based on these expressions only. Means in this expression you understood that x has to be taken as r cos theta and y has to be taken as r sin theta. Getting this point? So in this case we are going to use the r squared theta only, d theta only. All right. And so x square plus y square value we already know. So just put them. Just put them. Okay, just remember this catch that what I just said. If the x square plus y square is involved in the whole expression as well as this x dx plus y dx and x dy minus y dy, y dx is involved. In that case, use the results which are aligned with the x is equal to r cos theta and y is equal to r sin theta. But if in the question they are giving you x dx minus y dy or x dy minus y dx, whatever is there, and but along with it they are not giving you x square plus y square. Instead of that, they are giving you x square minus y square. So in that case, you will assume that directly that x is equal to r sec theta they are talking about, and y is equal to r tan theta they are talking about. So based on them, we have to choose the result, or we have to use these results. Okay. Now just directly put that and get the answer. Putting in equation 1. This is the equation 1, let's say. So numerator will become r dr, denominator will become r square d theta, and this will become 1 minus x square plus y square is r square only, and this is r square. So what we are getting, r dr upon r square d theta is equal to under root of 1 minus r square, and this is a square and root is gone. So r and 1 r is gone. This r and this r is also gone. So finally you are getting dr by d theta is equal to under root of 1 minus r square. Okay, let's go to the next page. So finally we are getting that if we try to separate the variable directly, this is the way we can do that. You can see dr by d theta is equal to 1 minus r square with under root. So under root 1 minus r square we have taken the denominator. Now just do the integration both sides and get your answer. Integrate both sides. So when you do the integration, this is the standard integration, I think. Okay. 1 upon under root of 1 minus r square. What is the answer for that? Sine inverse of r is equal to theta plus c. So r value, we can replace the r value. We already know sine inverse of x square plus y square with under root is equal to, we can also replace the theta value. Okay, I'm writing here because we have already assumed that x is equal to r cos theta, y is equal to r sin theta. So x square plus y square, we have already assumed, we can prove that this is r square, and y by x is equal to tan theta. So from there we can say that theta will become tan inverse of y by x. So here also we are going to write that tan inverse of y by x plus c. This is the final equation. Okay, is this clear, everyone? So which option? First option is correct. So one question I have solved it for you. The next question I'm giving you to try. Okay, this first option is correct. Second question. Can you quickly try it and tell me which option is correct? Yes, anyone got the answer? Or at least give me a approach. A option. Okay, you are saying the previous question. This one. What is the answer for this question? Can you see x square minus y square is also given, x dy minus y dx is also given, and x dx and minus y dx y dy is also given. Yes, Sujit, tell me. Yeah, tell me. Exactly, correct. Hmm. Correct. Hmm. Not sec square, it is sec only. Yeah, correct. No, no, yeah. Okay. Correct. 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 Mm-hmm. Hmm. D is the correct answer. Good. Okay, the approach is very clear to everyone, I think, if you have heard him. Otherwise, let's solve quickly. So here you can see x times of x dx minus y dy is equal to 4 times of under root x square minus y square into x dy minus y dx. It is given. Okay. And we just discussed that whenever this negative sign is involved, there are different set of formulas. Okay. So we discussed that x is equal to, we have to put r sec theta and y is equal to r tan theta. Then we can say x square minus y square will become r square into sec square theta minus tan square theta, which is 1 only. So we can directly say that it is r square only. And based on this, we have the results. X dx minus y dy can be represented as r dr. Okay, this first one is same. This first one result is same for as the last one, right? As the last result also similar to the last result. But the second one only different. So it is x dy minus y dx is equal to r square sec theta d theta, right? The only thing the difference is there here is the negative sign is involved. So whenever the negative sign is involved, sec theta and tan theta will come into the picture. So let's solve this now further. So let's put the values quickly. So x value is r. Okay, this color is not visible. X value is r sec theta into the bracket part. This one x dx minus y dy is equal to r dr is equal to 4 times of x square minus y square is nothing but r square. So under root of r square into x dy minus y dx. What is the value? R square sec theta d theta. Okay. So you can see in the left side you are getting r square sec theta dr is equal to 4 times of, this will become r only, r into r square will become r cube into sec theta into d theta. So here it is clearly visible to us कि sec theta and sec theta is gone, r cube and this r square is gone, one of the r will be left, and finally we are getting it as dr upon r is equal to 4 d theta. Now the favorite part, to integrate both sides. Let's go to the next page. So we have got dr upon r is equal to 4 d theta, and we are doing the integration. So this will become definitely ln r is equal to 4 times of theta plus c. So here we can say r will become e to the power 4 theta plus c, antilog. Okay, if you take antilog on the both sides. After this, I can write this as e to the power 4 theta into e to the power c, and this c can be taken as another constant, which is, I think, in this option is represented by a. Okay, so in the option it is represented by a, so we will take this a into e to the power 4 theta. Now you have to just find out the value of theta. Okay, how do you find out the value of theta? You know that x is equal to r sec theta, y is equal to r tan theta. So we will take y by x, that will become r tan theta upon r sec theta, and tan theta is sine by cos, it is 1 by cos, so I think r and r is already gone, so it will become 1 by, sorry, sine theta only, na? So sine theta is equal to y by x, so it means that theta is equal to sine inverse of y by x. Now just start putting this, put this value in here, and you will get your answer. Is that clear, everyone? So r will become a times of e to the power 4 times of sine inverse of y by x. And that is our final answer. Which option? Fourth option, I guess, right? A into e to the power, yeah. Fourth option is correct. If everyone have noted, you can write in the chat box.
Clear, sir.
Clear? Okay. Good. Let's go to the next part then. Now we have a next question. Next question is this one. It is saying that solve the differential equation x dy by dx is equal to y plus x tan y by x. Directly you can see in this case we cannot apply the polar substitution. Why? Because this tan y by x is involved here. Okay, as well as there's no format like x dy plus y dx or x square plus y square or x square minus y square. There is no format is given in this case, so we cannot apply the polar substitution. Okay, that is the identification of polar substitution. If those expressions are there, then we can apply. But in this case, we cannot apply this. So what should we do? Let's solve this, because from this question only we will start a topic which is known as homogeneous differential equation. Okay, so x dy by dx is equal to given as y plus x times of tan y by x. So can you see, if I divide the x on the both side, if we divide the x on the both side, we will be getting dy by dx is equal to y by x plus x and x is gone, and you are getting tan of y by x. This is, we call it as a homogeneous equation. But how do we know why it is called as homogeneous? What is the meaning of this?
Power of the equation is same. Like degree is same. Linear.
Degree is same. Exactly. Degree is same, or we can say linear. Right? In this case, it is linear. So till now we have not discussed that method. Let me tell you how to do that actually. Whenever the homogeneous equation is given, homogeneous equation is nothing but it is in the format of f of x comma y upon g of x comma y. Means dy by dx is equal to this format. If this format is given, means the numerator part is also the function of x and y. Denominator is also the part of function as a part of function of x and y, and at the same time their degree is same. Numerator as well as denominator degree is same. That is called as homogeneous equation. And in all these kind of homogeneous equation, if it is true, and if you see the y by x ratio, then you can directly replace them by like this. You have to replace them by put y is equal to tx or whatever you write, ux or vx. Okay, you might be seeing the NCERT, they will be writing vx like. So it's up to you, tx or vx, whatever is, or y is equal to tx. When you take the y is equal to tx, it is just simply like that. We have done the question, right? How we were reducing the equation to the variable separable form. We were replacing some values, no, and then we were differentiating. One question we have done, I guess. So the same thing we are going to do here. Same thing. So we will do. So we will say that y is equal to vx or tx. Okay, I am preferring this tx. So if y is equal to tx, differentiate both sides with respect to x. Tx, they will both be treated as variables. Okay, so tx product rule will be applied. So first as it is, derivative second is 1 plus x t by dx. So from now you will be replacing this dy by t plus x dt by dx in the equation 1. So put in equation 1. When you put in the equation 1, you will be getting t plus x dt by dx is equal to y by x will become t only. Okay, because from here y is equal to tx you have assumed, na? So y by x will become t only, plus it will become 10t. And I think t and t is already gone. You can see t and t is gone. And now it is a clearly variable separable format. So x dt by dx, I'm going to the next page. X dt by dx is equal to x dt by dx is equal to what was it, 10t, no? 10t only. Integrate both sides quickly and get your answer. Acha, before integrating, we have to separate them also, right? Separate them first of all. dt upon 10t, okay, and this will become dx upon x. Or further, we can say it will become cot t into dt is equal to dx upon x. Now it is fine. So cot t dt is equal to integration of dx by x. Integration of cot t is nothing but ln mod sin t, we can use, is equal to, this will become ln of mod x plus c. And from here we can say you can take this on the left side. So this will become ln of sin t minus ln of mod x is equal to c. Okay, and then you can apply the ln property. Log m minus log n, which will become log m by n. Right, is equal to c. And then further we can take anti-log on the both side. So you can say sin t upon x will be equal to e to the power c. And e to the power c can be treated as another constant, which is, let's say, k. So sin t will become is equal to kx, or we can say the sine of t value we have assumed as y by x. Replace the value again in the last, and this is the final answer.
Got it, sir.
Got it? Okay, let's go to the next one. So as I said, homogeneous differential equation, so this is the answer, sin y by x is equal to kx. So as I said, this was the next topic only.
Solution.
Sorry?
The last part, sir. Secondly, ratio
Yeah.
solution, last part.
Done? Okay.
Sir, why do we take the degree to give a dx?
Why do we take the क्या? Oh, sorry?
F of x, why we take to degree, sir?
Your voice is echoing. Can you mute yourself and again unmute? Tell me. No. Yes. No. No. X comma y. Right? Because the function can be of both. Okay, it can be in terms of x and y both. Like it can be like this also: x square y plus y x square upon x square y. Like this, the function can also be present. So we have to check the degree of the numerator as well as the denominator if it is same or no every time. Okay, that is the next topic only. See, a differential equation of the form of dy by dx f of x comma y upon g of x comma y, where f and g are homogeneous function. Remember that these functions should also be homogeneous function. What are the homogeneous function? Suppose that if I'm giving an example like this, x comma y is given as xy plus 1. Is it a homogeneous function? Anyone can tell me? Is it a homogeneous function? And tell me that whether is it a homogeneous function? F of x comma y and g of x comma y I have written here. So you will say that no, because in this case, but this 1 is a constant, is not having any degree. So this is not homogeneous. Okay. Similarly, it is also not homogeneous. However, if I take another example, let's say f of x comma y as xy square plus y x square, is it homogeneous? Of course, because total degree of each term is 3. Okay, so this is how we will be taking the degree of each expression. And when it is happening, so it is saying that the homogeneous function of x and y of same degree, then substituting y is equal to dx, it can be converted into the variable separable form easily. Okay, this is the expression. I hope that this is clear.
Yes, sir.
Okay, this is homogeneous of degree 3. Let's go to the question then. First of all, tell me the equation whether it is a homogeneous or no by looking at it. By convert this first of all dy by dx and means equate everything to the dy by dx and then check whether this is homogeneous or no.
Yes, sir. Homogeneous.
Homogeneous, no? Actually, we don't need to put the dy by dx also in this case because degree 2 is here, degree 2 is here, degree 2 is here. So each term is having degree 2. Left hand side, right hand side, both are satisfied. So it means it's a homogeneous equation. Okay. So we can say since dy by dx, when we write this for this question, which will become what? 2xy plus y square upon 2x square. So you can see that in the numerator also each term is having degree 2. It is also having degree 2, and the denominator is also it is having degree 2. Multiplication of constant will not make any impact on the degree, right? But addition will make. Getting this point? Because addition is actually giving you the whole extra term. So therefore we have got the homogeneous. So we will write here a line here. Okay, we will write one line here which is saying that the given equation is a homogeneous is in homogeneous form with degree, what is the degree? 2. So therefore we can write this equation in terms of y by x, or we can say we can replace the value of y as tx. Okay, we can replace the value of y as tx directly. So let's directly say that. So y will be written as tx. So what is the value of dy by dx will become? Again the same thing. It is t plus x dt by dx. This is, let's say, the equation 1. Now replace the values and solve. So put in the equation 1. So it will become t plus x dt by dx is equal to
First option, sir.
2 times of x. First option, check it again. Then y value will be tx.
Second option, sir. Second option.
Second is correct. The denominator will be having 2 times of x square. Okay. So t plus x dt by dx will be equal to, it will become 2t x square plus t x square upon 2x square, and you can see the right side it will become 3t x square upon 2x square. X square and x square is gone, and you are getting t plus x dt by dx. Now I think it is very simple. Okay, variable separable will work here. So t plus x dt by dx is equal to 3t by 2. I'm going to the next page. T plus x dt by dx is equal to 3t by 2. When you take this t on the right side, 3t by 2 minus t will become how much? T by 2 only. So x dt by dx will become t by 2. And now I think we can replace it. Dt by t into 2 is equal to dx by x. Okay. So 2 we can take on the right side also if we want. So dt by t is equal to 1 by 2 into dx by x. Integrate that both side. So we will be getting ln t is equal to 1 by 2 ln mod x. Have we done the mistake somewhere? I also thought. Correct. In the previous one. Correct. Actually, it is 2t x square only, na? And it is finally okay. Yes. Still x square will be cancelled out, right? Still x square will be done, and we will be getting t plus t square by 2 finally. Yeah, t and t is gone then, and we are getting x dt by dx is equal to t square by 2. Yes, now it is fine. So this is already gone, and still we are getting t square by 2. So we are getting t square by 2, na? Okay. So this is t square by 2. Do the integration. First of all, convert that like this: t square is equal to dx by x 1 by 2. Do the integration. Dt by t square is equal to 1 by 2 dx by x plus c. So finally, when you do the integration, you will be getting this expression as minus 1 by t is equal to 1 by 2 ln of mods x plus c. This is, let's say, first equation, and then you can start putting the boundary condition they have given. Okay. First of all, replace the t value by y by x. So it will become x by y because t was assumed to be as y by x is equal to 1 by 2 ln mod x plus c. Now apply the condition. So it is given that at x is equal to 1, y is equal to 2. Okay, that was the coordinate 1 comma 2 is given. So therefore we will put in the equation. Let's say this is equation second. I think first we have already used. Second, third. Yeah. So put this in the third equation. We will be getting how much? Minus 1 by 2 is equal to 1 by 2 ln of mod 1 plus c. You know that this value is 0. So the c value will be minus 1 by 2. And hence the equation will become, so equation 3 will become, this will become minus x by y is equal to 1 by 2 ln mod x plus, not plus, minus 1 by 2. Now the question is asking f of 1 by 2. What is the meaning of f of 1 by 2? They are asking you the value of y at x is equal to 1 by 2. Okay, just put the value of x as 1 by 2 and get your answers. So answer will be B option. B option you will be getting. Put x is equal to 1 by 2. This is the final equation. Let's say this is fourth equation. So put x is equal to 1 by 2 in equation fourth. So minus x, we can simply either we can find out the value of x directly, y directly. So the value of y will be nothing but, when you solve it, it will become 2x upon 1 minus ln of mod x. Okay, now put the values. So 2 times of 1 by 2 upon 1 minus ln of 1 by 2. So this will become 1 upon ln 2, 1 upon 1 plus ln 2. Okay, is it clear? So which option? Second. Everyone is clear with this question?
Yes, sir.
Okay. Let's go to the next question. It's a simple question. Okay. So B is the correct answer. In this question, you just have to tell that which of the following represents a homogeneous differential equation. Where is the question? Yes. Tell me your answers in the chat box. B option. Someone saying D, someone saying B.
Fourth option, sir.
Some students are confused in B also. Yes. Actually, the answer should be fourth only. Okay. D is the correct answer. As I said, the function, the f of x comma y upon g of x comma y, they both should be the function of x and y. Okay. But in this case, if you see, what is the given? The first one to directly eliminated because one is having 0 degree, it is having 2 degree. It is eliminated directly. Okay. Now see carefully for the sin x. Is it having any degree? X is having 1 degree, y is having 1 degree. But is it having any degree? We don't know. Okay. For the trigonometric function, we can't define any degree. Right? So this will be discarded due to that. So trigonometric functions are involved. We'll not say that this is a differential equation. Sorry, homogeneous differential equation. Similarly, log function. Can we define the degree of log function? No. This is having 1 degree, this is having 1 degree, and this is again undefined. So can't say about the degrees. This is having 1 degree, this is having 1 degree, this is also having 1 degree. Means numerator and denominator both are having the same degree. So answer is D option. Is that clear, everyone?
Sir, why not option A?
I told you, na? Option A, 1 plus x square is given. I said that each of the term should have a same degree in order to have a homogeneous. Yeah. Okay.
Got it.
This is not having same degree. So for this, answer is D option. Let's go for the next question. Solve the differential equation dy by dx is equal to x plus y plus 1 upon 2 times of x plus 2y plus 3. This kind of question we have done earlier also. Try this quickly and tell me what should we do here. Now slowly we are moving towards our third topic of today's session, that is equation reducible to homogeneous form. And after this, one question, last question, and then we're done. Yes, any approach, anyone, or any hint for this question? Yes, tell me. Correct. Simplest approach. That will be the answer. Okay, so can I give you this as a try yourself question? The simple thing is that x plus y is taken as t. Okay, and then replace the value by differentiating this, replace the values. Right, so I'm giving you the answer also for this. The answer you can write. Note it down quickly. This is the answer. So this is your homework. Okay, let's go to the next topic now. Equation which are reducible to homogeneous form. So it means that by looking at the equation, they will not look like they are directly homogeneous, but by some modification, we can convert them into the homogeneous form. Okay, so what are those modifications? Let's see. So suppose that if equation is given in this format, dy by dx is equal to a1x plus b1y plus c1 upon a2x plus b2y plus c2. It means what? What it is representing? It is a line, na? Equation of line. General equation of line. and this is also the equation, general equation of line. So just remember like this: if dy by dx is equal to a line 1 equation of line 1 upon equation of line 2, and if this is the condition, this condition is being true, a1 upon a2 is equal to b1 by b2, then we will use the substitution a1x plus b1y is equal to t. Same thing we have done in the previous question. So can we say that if a1 by a2 is equal to b1 by b2, these are parallel lines? Yes or no?
Yes, sir.
Okay. So it means that whenever the equation dy by dx is given in the format of equation of line 1 upon equation of line 2, which are parallel, in that case, you will be using the first two expressions as t, and then the equation will reduce to the variable separable form. So let's understand one question on it. Okay. This is the question. Let's try to solve it, or you want to try? Okay, I'm giving you time. Try this. First of all, tell me that whether it is a homogeneous or whether it is a reducible to homogeneous.
It's directly homogeneous, sir.
It's directly homogeneous, correct? Because dy by dx is given as x plus 2y upon x minus y. Each term is having degree 1 in the numerator as well as denominator. So we can say it is directly homogeneous. We will write this as given equation or given differential equation is homogeneous of degree 1. Okay. So given differential equation is of degree 1. So then simply we can say we can use the y is equal to tx value. Okay. Differentiate both sides. We will be getting dy by dx is equal to t plus x dt by dx. Put that in the equation 1. Putting in equation 1. So it will become t plus left side will become t plus x dt by dx, and the right side x will remain as it is and y will become tx upon x remains as it is, y will become tx. And I hope that I can see that x and x can be taken as common from both numerator and denominator. So it means that x can be cancelled out. So we will be getting t plus x dt by dx is equal to 1 plus 2t upon 1 minus t. Right? This t can be taken on the right side, and we can take the subtraction. We can do the subtraction here. So this will become 1 plus 2t upon 1 minus t minus t. Take the LCM. So this will become 1 plus 2t minus t minus will become plus t square upon 1 minus t. X dt by dx. Okay. So this will become t square, then plus t, then plus 1 upon 1 minus t. X dt by dx. Replace the values. Okay. First of all, I'm just writing this. I'm modifying this little bit. What I'm doing, I'm taking the negative sign common from the denominator. Okay, so I have taken the negative sign common from the denominator. So now we can separate variable separable form, right? So dt upon this will become t upon t minus 1 upon t square plus t plus 1. That negative sign will remain on the right side only. So dx by x with a negative sign. Okay. Now this equation we have to solve. Let's go to the next page. So we have got t minus 1 upon t square plus t plus 1 into dt is equal to minus dx upon x. Now we are going to do the integration. We have to do the integration, integrating both sides. So when we do the integration on the both side, it will become t minus 1 upon t square plus t plus 1. Now the real challenge is here. How to do this integration? Yes.
Sir, splitting it into two parts.
Splitting it, which one? Numerator part.
Yes, sir. Numerator. Or multiplying
But
by and dividing by 2.
multiplying and dividing by 2. Partial fraction will work here or no? Tell me.
Sir. Partial fraction.
Why?
Sir, because instead of partial fraction, we can easily make the numerator come as the derivative of the denominator, and so we can use the formula, the log of denominator.
We can use the partial fraction also, right? There is no doubt. There is no issue in that. If I say that t minus 1 upon t square plus t plus 1 can be taken as what? But how will we take? For this part, we need the factors now. We need the factors. So how will we take? It's not possible, I guess.
Yes, sir.
Yes, sir, not possible.
Sir,
Not possible, no? Partial fraction. Yes.
sir,
Yes. Tell me.
sir, this exactly same question is given in the ancient example, sir. So they multiply, yes, sir, in the text,
No.
they multiply lambda to the function, sir. And that's how
Lambda to the constant.
Yes, sir.
That's way it can work.
That's how it
But
works.
correct. But rather than doing that, one student has suggested that multiplying by 2 and numerator and denominator. Actually, see carefully. What we will be doing, we'll be converting the numerator part into the differentiation of this part. What is the differentiation of this part? 2t plus 1. So we will try to convert this so that we can do the substitution later. So what I'm doing, I'm multiplying by 2 and dividing by 2 on the numerator and denominator. This is the first part. Okay. But we need 2t plus 1. So we have to add. We have to add what?
Plus or minus 1, sir.
No.
So we can
Plus or minus 1. Yeah. Plus or minus 1 will also work. Correct. So plus or minus 1 will work easily. Okay, so we can directly say that add 1 and subtract 1. So this will give you what? Integration of 2t plus 1 minus 3 upon t square plus t plus 1 dt is equal to minus dx upon x, and then separate that. This will become 2t plus 1 upon t square plus t plus 1 minus 1 by 2 will come along with it into 3 will also there. So dt is also there. 3 upon t square plus t plus 1 dt is equal to minus dx by x. Is there any doubt up to here, anyone? So in the first portion, you can do the substitution directly. There is no issue in that. In the second part, we will do the complete square, correct? So here we can say t square plus direct answer add the question. Whatever. 11.4 is what? No, so okay. This is du. Okay, so this integration can be done easily. But what about this completing square method? How to do that? Take the coefficient of t, take the coefficient of 2, that is 1, make the half of that and do the square. Take the coefficient of t, make the half of that, do the square, and then add and subtract. T square plus t plus 1 by 4. Okay, plus 1 is already there, minus 1 by 4. This is 1 by 4, right? So this will give you what? T plus 1 by 2 whole square, and this will give you 3 by 4. Or this can be written as t plus 1 by 2 whole square plus root 3 by 2 whole square. Why I am writing this, I will tell you. Because in the denominator, we are converting this format into x square plus a square format. Okay, so let's quickly solve this and we'll get the answer now. So in this case, the direct differentiation is there. So 1 by 2 into, it will become 1 by u into du. Okay,
Yes, sir.
in this part minus 1, sorry, this is minus 1 by 2. Minus 1 by 2 into 3 upon, this is t plus 1 by 2 whole square. We have modified it, plus root 3 by 2 whole square. And equal to, it will become 1 by x dx, means ln x. Okay, ln mod x or ln x, you can write mod x actually. This is not 4, this is u. Okay, so 1 by 2 ln of mod u is minus 1 by 2 1 by x square plus a square. What is the formula for that?
1 by a into tan inverse of x by a.
Correct. That formula we have to use. So minus 1 by 2 into 1 by a. 1 by a. What is a here? Root 3 by 2. So root 3 by 2, that means 2 by root 3 into tan inverse of t plus 1 by 2 upon root 3 by 2 is equal to minus ln x. With mod sign also we can apply plus c. And then replace the value of u and t in terms of x and y, you'll get the answer. So final answer I'm writing. Okay, final answer I'm writing here. Replace the values, all values. You will be getting log mod of x square plus xy. See, this question is not very conceptual, rather it is lengthy. Okay, tan inverse of upon x under root 3. Sorry.
So log of that x square plus y square plus xy, won't it come in the under the root?
Under root 3 by 2, huh?
No, sir. That log of x square plus y square plus xy term, won't it come under root, inside the root?
Inside the root. So we have taken the power outside. Okay, later.
Okay. Yes, sir. Yes, sir.
Okay, by the log property, we have taken the the power outside, and then
Yes, sir.
take on the right side.
Yes, sir.
Okay, final answer. This is the final answer.
Got it, sir.
All right. So this is the question. This is the answer, and this is the last question I'm giving you. One more question. Take this question as a homework. Okay. For this, the answer is also given. You can write this answer.
Yes, sir.
This is the answer. All right. So this is it for today. Hope you all enjoyed it. And now if you have any doubts, then you can ask me.